Hello my dear students, welcome back to the session. In the last session, we discussed 25th problem, right? So let's look at now 26th problem. Let's read that problem here. If the total power is 1100 watts, find the power in each resistor and the reading on the ammeter. Okay? So find the power of each resistor. That means he's asking what is the power of 3 ohm, what is the power of 10 ohm, and he's also asking what is the ammeter reading. Ammeter reading is always like RMS magnitude. Yes or no? Okay. So because meters reads only RMS magnitudes. Now let's try to find all these things here. What did he give actually here? Total power he gave. Total power means what? This entire circuit is consuming 1100 watts. That is active power is given of the total circuit. Total circuit means what? First of all, if you find the total resistance, that is Z equivalent. In that Z equivalent, whatever the resistive part is, the real part is there. Okay. The power consumed by that real part is nothing but what? 1100 watt. Yes or no, all of you? Okay. So that is what given actually here 1100 watt. Let me replace this entire circuit by to find the total current I'll get here, because already I know total power. If I find the real part of this impedance, then you know that active power is nothing but IR square R. Yes or no? So R is known, P is known, we can find the I. Once you know the current, you can divide this current among these two branches, find the current here, that is opposite impedance by total impedance into total current, then find the magnitude of it, square into 3 ohm, you'll get the power. Similarly, I2 also you can find. Yes or no? Okay. So therefore, Z equivalent let us find first. 10 parallel 3 plus J4. Let us simplify it and we'll get the value here. The Z value, you will get 10 into 3 plus J4 by 10 plus 3 plus J4. This is what the total resistance here. So I just give you the resistance, the total impedance part here. I can give you just a minute here. 10, yeah, let me calculate it. 3 plus 4I whole inverse, then whole inverse. This is what 2 point, you got 2.972 plus J 2.162 ohm. Okay, so this is what actually Z equivalent. You understand? This is what Z equivalent you got. Now in that the resistive part is this, right? So therefore I square into, okay, what is this actually? P, total P is nothing but total impedance real part into I square, that is current flowing to that, into 2.972. From this I get here, okay, I is nothing but already you know this value, how much here? 1100 watt. Understand all of you? Okay. So once you calculate that, you will get that I value as 19.245. Okay. So I think you got that answer here, ammeter reading. The ammeter reading is nothing but what RMS magnitude of that current only. Yes or no? Okay. Then find the I1. And you want power of the 3 ohm. So say this is I1 and this is I2. So what is power of 3 ohm? I1 RMS magnitude square into 3, right? So let us deal with only magnitudes here. So what is that opposite? 10 by, okay, then magnitude of 10 plus 3 plus J4. I hope you understand this. Into, what is this magnitude total current I? This is 19.245. Clear off, you take the total magnitude, the denominator part. So you get this value, I can give you 14.149. So power of the 3 ohm is nothing but RMS magnitude, that's 1 square into 3, that's nothing but I1 square into 3, that's nothing but here you will get 600 watt. Okay, you will get what? 600 watt. So once you get 600 watt, what is the remaining power? Because according to the Thevenin's theorem, the total active power must be sum of the active powers consumed by the loads. Total power is known, therefore the two resistors are consuming the power. This is consuming 600. The remaining power of this 10 ohm will be definitely what? 1100 watts minus 600, that is 500 watt. Or else you can find I2 also. I2 is nothing but what? I2 is nothing but magnitude of 3 plus J4 by magnitude of again 10 plus 3 plus J4 into 9.245. then you will get some current, and that current square into this 10 will also give you the power. Okay, so please note down. This is how you can find the powers, and then we move on to another problem, 27th problem. I think you understand the total power is given, total impedance I found. In that, the real part, whatever the real part is there, that is the total resistance. Now the total resistance is consuming 1100 watt. So from that I could get the relation I square. I is nothing but current flowing here, the total I. Okay, I square into this resistance will give you 1100 watt. From that I can find magnitude. That is nothing but ammeter reading. From that I can find current division rule I can use and find the remaining things. 27th problem. The periodic triangular current, let me read it. The periodic triangular current shown in the figure has the peak value of 180 milliampere. Find the average power that this current delivers to a 5 kilo ohm resistor. Okay, suppose if this current is sent through a 5 kilo ohm resistor, what is the average power that is consumed by the resistor is asking. Okay, what is the average power? Average power, active power, real power, everything is same, right? So instead of giving the total value of that current, he has given here the waveform. But you know the formula for average power. What are the formulas you have? P is equal to VI cos phi. That doesn't work because we don't know what is V. P is equal to V square by R. That doesn't work because voltage is not known here. P is equal to I square, IR square. IR means what? IR magnitude, that is RMS. P average is always, remember, I RMS square into that resistance R. So you need to find RMS value of this particular waveform. But you know that I RMS value very clearly when you have some triangle, rectangle, trapezoid. I gave you one shortcut technique when we discussed the periodic waveforms in the initial class of fundamentals of AC circuit. Okay, denominator, that is total time period, you know very well, right? What is the time period of it? So T is equal to capital T. You know that very well, yes or no? So you got, let us say, 0 to T by 4, T by 4 to T by 2, T by 2 to 3T by 4, 3T by 4 to, yes or no? Then T. So you got 4 different intervals. And I told you to take differently because this is one ramp, this is another ramp, this is another ramp, these are 4 ramps are there. So when there is a ramp step, I told you already technique. So what is the magnitude of the first ramp? IP square by 3, I told you, right? Into what is the duration of the ramp, distance of the ramp, okay? That is time of the ramp, T by 4. Like that you have another ramp, the same magnitude, another ramp. This is minus IP. Please note down this, okay? So again, minus IP or plus IP whole square will give you plus only. Again, this one also same. So therefore, totally 4 ramps are there. So 4 get cancelled and TT will get cancelled. And finally, you got with IP by 3. So 180 milliamperes by 3. Understand all of you, okay? 180 by 3. So what do you get 180 by root 3, not 3, IP by root 3. Okay, so IP by root 3, that is 180 by root 3. Now what is average power? P average is nothing but IP 180 milliampere minus 3 whole square by 3 into 5 into 10 power 3. Okay, because when you take square, root 3 whole square, you get 3 and 180 milliampere square and 5 into 10 power 3 because of 5 kilo ohm, and finally you are supposed to get an answer 54 watt. Please check with your calculator, you can get that answer. Okay, so please note down that. Meanwhile, I just remove this part. Quickly note down. That is 27th problem. Then we'll move on to 28th problem. This question was asked in GATE. It's a GATE previous question. The current I of t through a 10 ohm resistor. 10 ohm resistor in series with an inductance is given by I of t is equal to 3 plus 4. All of you read the question. 4 sine 100t plus 45 degrees plus 4 sine 300t plus 60 degrees amperes. The RMS value of the current and the power dissipated in the circuit are. So when you have multiple frequencies, okay, a sinusoidal function with multiple frequencies, one DC component. Yes or no? So he's asking what is the RMS value. Average value is a DC component. Yes or no? I average, if somebody is asking, he did not ask, but we can find. What is this 3 only? But what is IRMS? What is IRMS? We can say root 3 square plus 4 square by 2 plus 4 square by 2. Yes or no? Finally you get 5 amperes. What is the power? Average power is nothing but IRMS square. Yes or no? IRMS square into resistance. So already this is 5 square into resistance is how much? 10 ohm, 250 watt. Clear? Very simple question. Let us see now 29th question. This question was also asked in GATE. Please note down. Meanwhile, I just remove this. 29th question. What is the 29th question given? So that's a simple problem. 28th one is very simple problem. 29th question. The circuit shown below is driven by a sinusoidal input. Vi is equal to Vp cos t by Rc. The steady state output is, okay, 29th problem. This question was also asked in GATE. Okay. This question was also asked in GATE. This is plus minus V naught. This is C, this is R, C, and Vi. Okay, so he's asking what is V naught. So the V naught options were also given. I think you already have the options. You can see ABCD options were given. Okay, so how do you deal with these problems? Usually when Vi is given, what is Vi actually given here? Vi is given Vp cos T by Rc. Okay, this is R into C divided by T divided by R into C. So when the circuit is excited by the sinusoid, I told you already, I can go directly converting the time domain circuit into, okay, complex form or phasor form. Some people convert into S domain also. This becomes 1 by Cs. This becomes 1 by Cs. S domain circuit 1 by Cs. Where S is equal to j omega, they can substitute at later point of time. Omega is given how much here? 1 by Rc. Yes or no? What is the frequency of the sinusoidal supply that you have? Omega is equal to 1 by Rc, that you can substitute and you get some final value. So convert into S domain, then finally substitute S is equal to j omega, then substitute omega is equal to 1 by Rc, you get some answer. Okay, that is a phasor form or RMS form or whatever. Then again you have to come back towards sinusoid. Or else you convert into complex form. Complex form is nothing but what? This one is minus jxc. Yes or no? Minus jxc. This one also minus jxc. What about this? This one is Vp at an angle of 0. I'm taking maximum value here, not RMS value. Okay. I'll come back again with the same maximum value when I convert from phasor form to or complex form to sinusoid. I hope all of you understand it. Okay. Or some people take by root 2 also. I told you already, nothing wrong in that. But you have to again come back with multiplication of root 2 to get the maximum value. Now coming to here, what is this? Can I say this is Z2? Can I say this is Z1? Yes or no? Z2 and Z1. Now see here, minus Jx. What is Xc? 1 by omega c. What is omega? 1 by Rc. Yes or no? 1 by Rc into what? C. That means XC value is R. That means this becomes what? Minus JR. This becomes what? Minus JR. That means Z1 becomes R minus JR. Okay. Z2 becomes, you have Z2, okay. Z2 becomes R parallel minus JR. That means minus JR square by R minus JR. Clear? Now, what is VI? It gets divided into two parts. Voltage division rule I can apply. So, V naught is nothing but Z2 by Z1 plus Z2 into what? VI. Clear? So, you require definitely Z1 plus Z2 in the denominator. So, what is Z1 plus Z2 also? Let us try to find. What is Z1 plus Z2? You add these two. So, R minus JR, okay, you get minus JR square by R minus JR. Yes or no? So, what you'll get here? You get R square, clear? R square minus JR whole square, okay, plus JR whole square minus J 2 times R into JR, nothing but 2R square minus JR square by, what is this? R minus JR. I hope you understand the point. Okay. Now you get, look at this, minus J square into R square. Minus J square is minus 1. So R square into minus R square will get cancelled. Finally, you are left with what? Minus J 2R square minus J R square. Finally, you are left with, okay, minus J 3R square by R minus JR. I hope you understand the point. Once you substitute here, then what will you get here? Z2. Z2, what is Z2 actually here? Minus JR square by R minus JR by. What is Z1 plus Z2? Minus J 3R square by R minus JR into VI. These two get cancelled and J get cancelled. R square minus. Finally, you are left with what? VI by 3. That means V naught of T will become, what is VI? VP. That is VP by 3 cos, what is that? Cos 2T by RC. This is what your final answer. Understand? What is the option given? Option A. VP by 3 cos T by RC. So that's your answer. Quickly note down all of you. 29th problem we have finished. We'll move on to 30th problem. Just note down. Meanwhile, I just note it down. Note down another problem here. So some people use the method that 1 by CS, they use 1 by CS. You can simplify, it doesn't matter. You can convert it to S domain and then you can also proceed. It doesn't matter. Okay. Hope you have finished this part. Please do that. Meanwhile, I can note another problem here. I just note another problem. T plus 10 degrees plus 10 root 5 cos 2t plus 10 degrees. I think you have finished that problem, right? So let me read it. An input voltage V of t is equal to, given that voltage here, look at this, 10 root 2 cos t plus 10 plus 10 root 5 cos 2t plus 10 is applied to a series combination of resistance R is equal to 1 ohm, inductance L is equal to 1 Henry. Okay. The resulting steady state current I of t in amperes is, some 4 options were given. Okay. So what is it asking actually? Voltage is given, resistance and inductance is given. Probably you can find impedance from these two if you know the frequency. Then once you know the voltage and impedance, you can find the current. But The voltage is given not with a single sinusoid function. Here multiple signals are available with different frequencies, or a single voltage with multiple frequencies, you can say. Understand all of you? When you have a voltage with multiple frequencies, okay, when you have voltage with multiple frequencies, generally, because you know that impedance I is equal to V by Z, you know that very well, but impedance is always a function of what? Function of frequency or not? It is dependent on frequency. So when you have a voltage with multiple frequencies, then what will happen? How can you handle this kind of problems? Remember always, whenever you have a voltage or current or whatever with multiple frequencies, use superposition principle. I hope you understand this. You can also treat it as what? Sum of two voltages. V1, this is V2. It is as good as two other input signals added and to get the total input signal. So find what is I due to V1, what is I due to V2. Yeah, both are different because this is having 1 radian per second, this is having 2 radian per second, and impedance is a function of frequency. Then obviously the current will change for two different voltages. Understand all of you? Though the magnitudes, here the magnitudes are different, but even if you have magnitude same, because the frequencies are different, the current will change because the current is a function of Z is a function of frequency. Clear all of you? Therefore, I can find, use the superposition. Use superposition. You can put a note and write down. When multiple frequencies involved in the given input, then use superposition to solve the problem. Okay, so due to V1, the response due to V1. What is the response? Let us say this is I1. And what is the frequency here you have? Omega is equal to 1 radian per second. Okay. So what is now Z? Z is equal to, you got 1 plus J, 1 into 1, that is 1 plus J1, nothing but root 2 at an angle of tan inverse 1 by 1. 1 by 1, nothing but how much? It is 45 degrees. Yes or no? This is nothing but what? 45 degrees. So what is actually now I1 of t? I can directly put it. What is V1? 10 root 2 by magnitude of Z. 10 root 2 by magnitude of Z. Root 2. Cosine you take as it is because, as you know, voltage by Z, magnitude by magnitude, and cosine of angle minus angle because denominator, right? So therefore cos t plus 10 degrees minus 45. Nothing but what? You have minus 35. Clear all of you? Okay. Now due to the response due to, okay, I of t due to V1, I of t due to V2. So what is that response? You call it I2. And what is that frequency you have? 2 radian per second. Then what is Z? Actually you have 1 plus J, okay, omega L. What is omega? 2, okay, L 1, right? So therefore 1 plus J2, nothing but root 5 at an angle of tan inverse, okay, 2 by 1. Now let's find what is I2 of t. This is V2, right? V2 by Z. What is V2 magnitude? 10 root 5 by 5. 10 root 5 by 5. Root 5. Okay. Here these will get cancelled. These also got cancelled here. Okay. Then what do you get here? Cos 2t plus 10 degrees minus, right? Because in the denominator, right? Minus tan inverse 2. That's it. So what is the total response you have? The total response is, now the total response you can write as, what is that? I of t is equal to I1 of t plus I2 of t according to superposition. So which option is correct here? You can say 10 cos t minus 35 plus 10 cos 2t plus 10 minus tan inverse 2. Option C is correct. Clear all of you? Okay. Complete it quickly. Meanwhile, I just take this off. Okay. Complete it. So what is the logic you are implementing? When you have multiple frequencies, then deal with superposition. Always deal with superposition. Okay. When you have multiple frequencies, when multiple frequencies are involved in a given input, then deal with problem using superposition. Clear? You note down that. Meanwhile, I just note another problem here. This problem was also asked in GATE. I just draw the circuit. Okay. Minus J4 ohm plus J4 ohm, 6 ohm, 6 ohm, 6 ohm, 14 at an angle of 0. You're just asking what is I? Some options were given. Hope you have finished that, right? So this is what the circuit. Now please refer your classroom workbook, 31 problem, 31st problem, okay? So quickly note down that circuit. Is asking what is the total current delivered by the source. So it's a very simple problem. Okay, we did several problems in DC circuits. The difference between the DC circuits and AC circuits is what? Okay, you deal with complex numbers in AC circuits. Okay, so we already entered into AC steady state analysis already. Okay, we're just finding the steady state response. Already we entered. Okay, we learned fundamentals and we also entered into AC steady state analysis. AC steady state analysis deals with what? Node analysis, mesh analysis, and then you deal with the theorems also. Yes or no? AC theorems. So we'll discuss the AC theorems a little later. But now let us see this problem, 31st problem, total current. Total current is nothing but what? Total current is nothing but total voltage by total impedance. So let's find the total impedance. To find the total impedance, let us solve here. It looks like a bridge, but it's not a balanced one. Why it is not balanced? Tell me. Minus J4 by J4 is not same as 6 by 6 because there is a negative sign actually coming in this ratio. So they are not same. Yes or no? And all elements are neither series nor parallel. Definitely star delta is the best opportunity to solve. And since they are having equal values, let us deal with this problem by converting this delta into star. Okay, by converting that delta into star here. So you have, what is this? 6 by 3 equal values 2 ohm. So here also it is 2 ohm. Here also it is 2 ohm. So finally you got this J4 in series with 2 ohm. This is also 2 ohm. Minus J4 in series with 2 ohm. So finally you got here. Minus J4 plus J4 ohm. This is 2 ohm and 2 ohm and 2 ohm. Okay, this is what the total impedance you are supposed to get. Now these two are in series, then parallel, then series. Yes or no? So the total impedance can be calculated. So 2 plus J4 parallel with 2 minus J4, the whole is in series with plus 2. Okay, so what do you get here? 2 plus J4 into 2 minus J4, 2 plus J4 into 2 minus J4 divided by 2 plus J4 plus 2 minus J4 plus 2. 2 square, okay, plus 4 square by, what do you get here? These two got cancelled and 4 plus 2. Okay, so 16 plus 4, 20, 20 by 4, 5, 5 plus 2, that is 7 ohm. So finally I is equal to, you got 14 at an angle of 0 by 7. This is 2 at an angle of 0 amperes. I hope you have 4 options in that 2 at an angle of 0, option B is correct. Okay. Please finish that. We'll move on to 32nd problem, which was asked in GATE earlier. It's a common data question. There are 2 questions given on the same problem. 32nd problem I'm talking about. This is a resistance and coil, inductor, and then capacitor. You have, this is IC, this is IRL, this is VS, this is IS. Clear? This is R, L, and C. Vs is equal to 1 at an angle of 0. IRL is equal to root 2 at an angle of minus pi by 4. Okay, nothing but 45 degrees. Is is nothing but root 2 at an angle of pi by 4. This is the data given, and the question number 1 was asking here. So what is the power dissipated in R? Power in capillaries. Some 4 options given. And then I'll move on to the second question. Okay, second question was what the current IC is. So first I deal with the first question and then I move on to second question. Okay, so please note down that circuit quickly. Meanwhile, I just remove this part. Okay, right. Now here, power in capillaries, how much, what is the power? See, to find the power, you have different formulas. Yes or no? What are the formulas that you can use? One is IRL, magnitude square into R. Or else, if you know the voltage, okay, the power in R can be determined. R, okay, you can use IRL magnitude square into R, or else VRL square by R. Okay, yes or no? So these are the 2 formulas you can apply. Or else, if you know the voltage across it, the total voltage, impedance, this is the impedance. The voltage across the total impedance is what? Vs. The current flowing to the total impedance is what? IRL. Then you can use Vs magnitude IRL magnitude cosine of, yes or no? Vi cos phi. But what is V? Voltage across the impedance. What is I? Current through the impedance into cos, phase angle difference in voltage and current. Cos of angle difference between Vs comma IRL. Clear all of you? Okay, this is how you are supposed to solve the problem. But what is the appropriate formula among these? Since you do not know R, this is not correct. This is also not correct. You do not know R, you do not know even VRL also. But VS, IRL, all these things. That's why I told you already, different formulas are there. Can be used, those can be used in different contexts based on the data given. Understand all of you? So this is the only formula we can use to get the value of power of R. That is, power of R can be determined. VS is how much? 1. IRL magnitude how much? Root 2 cosine of angle difference between, how much it is? Pi by 4. Okay, so that is why you got 1 watt, because this is 1 by root 2 into root 2. You got all those things. Okay, this 1 watt is the correct answer. Then coming to now question number 2, what is asking? IC. Simple. What is IC? IS known, IRL known. So you can apply Kirchhoff's current law at this point. You can get you can get here IC is nothing but IS minus IR. Yes or no? What is IS actually here? Root 2 at an angle of pi by 4 minus root 2 at an angle of minus pi by 4. So 1 plus J1 minus of 1 minus J1. 1 gets cancelled. J 2 amperes is correct. Okay, so that is option D is correct. Understand all of you? Okay, so this is how you can solve the problem. Note down quickly. Note down. 33 problem which was asked in GATE. You just note down. Meanwhile, I write the problem here. Okay. There was a resistor here, and this is what the coil. Some RL and X. This is a load actually. It is called, and the voltage across this load was called as V3. The voltage across this series resistor was given as V2, and the voltage here it is V1. Understand? So V1 value was given actually here. What was V1 value? Was given 220 volts. What is V2? 122 volts. V3 is equal to 136 volts. I think you have finished that part. Okay. Yeah, here is one important question in the GATE asked actually here. It is a linked answer type question. That means the first answer can be used in the second question. Okay. Without getting the first question answered, you cannot solve the second question. There is a link between the second and first question. The second question solution depends on the answer of the first question. You call them linked answer type questions. LAQ. Linked answer type questions. Nowadays, you are getting very, few questions on this, or sometimes he's not asking even LAQs. But you can treat all these LAQs as a common data questions because there are multiple questions, right? You can treat them. So read that here. In the circuit shown, the 3 voltmeter readings are V1 is equal to V2 is equal to V3. Some values are given. Then the power factor of the load is okay. So I think all of you remember I have explained you the phasor diagram concept when V1, V2, V3 is given when the practical inductor is connected in series with a resistor. Practical capacitor is connected parallel to a resistor. I gave you 2 important cases. Please refer back them. You will understand I gave you. The angle of this particular coil can be determined, or the power factor of this particular coil can be determined. I told you already, you take it as Z at an angle of theta. Okay, I gave you the phasor diagram concept. Take this I as a reference by taking the series circuit. When you take I as a reference, then V2 is in phase with I. Okay, V2. Then V3 leads I by angle theta because inductive. Okay, this is V3. This is angle difference, that is theta. Then you get the resultant phasor V1. I told you already this particular same concept in the previous classes. Okay, on the same thing. So you get angle phi. So I gave you the formula. Cos theta is equal to, remember all of you, V1 square minus V2 square minus V3 square by 2V2 V3. Understand? All are magnitudes and voltmeter is always magnitudes. Okay. So substitute all those things here. 220 square minus 122 square minus 136 square by, so 2 times 122 into 136. Okay. So what is cos theta? You will get here, if you solve, you will get approximately 0.45. Some 449, something like that you get. So approximately 0.45. The power factor of the load is he has given. Okay, so this phasor diagram concept I have already explained. and you can refer back your notes. You can easily understand. The two cases I have explained. One is a series resistor is connected in series with the practical inductor. Then a parallel resistor is connected across, across a practical capacitor. I have clearly explained when voltmeter readings are given how you solve the problem. Okay. Now here question number 2. Let's see how it is linked actually. If RL is 5 ohm, the approximate power consumption in the load is, understand? So power consumption of the load is asking. What are the different formulas you can apply for power consumption? Power consumption is nothing but active power or reactive power? Only active power. Power consumption is nothing but power consumed by the resistor. If it doesn't mention active, reactive, by default is active power. Remember all of you. Okay. If it is reactive power, he will specifically mention it is a reactive power. Clear? So what you get here, the power consumed by the resistor is, you can use PRL as, PRL as, you have different formulas. Let me use I square into RL. Understand? So V RL square by RL. What else? V3, the impedance voltage is how much totally? V3. What is the current? I. So V3 I cos angle difference between V3 comma I. Understand? These are three formulas. Now in this context, which formula is more suitable to apply among all these three formulas? You have to check. Understand? Does it work here because you do not know what is the ammeter reading? No. Since you do not know ammeter reading and ammeter phase angle, no. This is the only formula which you have to apply in this context. But do you know what is the voltage across RL? It is not directly given, but it is indirectly given. What is that? V3 you know, and how much angle it is making with respect to this I, because the angle of this impedance is taken as Z at an angle of theta, and this theta was calculated already because cos theta is known, then theta can be calculated. Yes or no? Now since from this you can see here, this is V3. The V3's horizontal component is what? VRL. V3's vertical component is what? Vx. You understand? See this? This is V3 horizontal component VRL. Okay. This vertical component is what? Vx. Understand? The horizontal component, vertical component. Therefore, the active power is nothing but here. You can use VRL is nothing but V3 cos theta in this context. Cos theta, okay, RMS magnitude square by RL. What is that value? V3. V3 is 136 into cos theta. Now you understand how it is linked. Unless you know cos theta, you cannot find anything here. You cannot find the power of RL. So 0.45 square by, what is R? 5. That's it. So if you just simplify V3 cos theta, you will get a value of 750 watt. Understand all of you? Okay. So V3 is nothing but 136 cos theta 0.45 whole square. If you want to find QRL, means Q of the load, okay, that QX, then you have to use what? V3. He did not ask, but I'm just finding out of my curiosity. So V3 sine theta whole square by, what is it? X. Actually, I have not given X. Okay, therefore I cannot find it. But in case tomorrow if he's asking, let us say, what is the reactive power consumed by or absorbed by the load, then you are supposed to find Vx. Then Vx square by X. But what is Vx? Is nothing but V3 sine theta only. Understand all of you? Tomorrow he may ask you, what is the power factor of the source? He asked you power factor of the load. But whatever the power factor of the source, the power factor of the source can be determined here. Okay, this can be asked, or power factor of the source can be asked. Power factor of the source. Then what is that? I think you know very well. Phi is equal to tan inverse. What was that? You remember all of you? Vertical components. Okay, vertical components. What was the vertical component here? There is no vertical component for V2, but V3 sine theta, V3 sine theta by V2 plus V3 cos theta. Do you understand? Sum of vertical components by sum of horizontal components. What is sum of vertical component here? So V2, okay, is a horizontal component. V3, what is that V3 actually here? V3 sine theta, V3 cos theta. So you get now, if you take a horizontal component, V3 cos theta, V2 plus V3 cos theta is the total horizontal value. Total vertical value is V3 sine theta, V3 sine theta, V3 sine theta by the total. Understand? So all these values are known now, including the theta, because cos theta is known, sine theta is also known now. Substitute here, you get angle 5. Then power factor of the source will be cos 5. Understand? You'll get the values. See, these two actually was not asked, but there is a possibility when he is asking those questions, why not these questions? Yes or no? So you have to think now out of box, because in GATE there is no repetitive questions. The concepts are repeated, but the questions are not repeated. So you can also extend the problem to that extent. Okay. So please quickly note down. This is very interesting. Okay. 33 problem was over. 34. It's a very interesting question asked in GATE. Okay. There are some interesting problems based on the phasor diagram concept. You must be remembering such kind of problems. All remaining you can easily handle. But there are some special problems, like 33rd problem is a special problem. 34th is also a special problem. So let me read that question here. In the given circuit, if R0 is adjusted such that magnitude VAB is equal to magnitude VBC, then some 4 options given. Okay, so the circuit was given like this. The circuit was given like this. Please redraw the network once again. Redraw the circuit here. The circuit was given in your classroom workbook. Please note down that once again. Now this is R0. This is Z at an angle of theta. This is capital R. This is also capital R. So this is A, C, B, and this is D. And this was given as V. Okay, so what did he give actually here? VAB magnitude is given as VBC, right? Then if he has given like, right? So this is a question actually. Okay, so please go through the question once again quickly here. Read the question carefully and observe what is the data given. What is the data given? You can observe. Okay. Clear? Okay. Now let's deal with this problem here. See what is the data given actually here. If he is asking VAB is equal to VBC, then some conditions were given. Okay. If you observe the first B and C, if you see, he has given VAB. What is the option A given? Option A is given theta is equal to 2 tan inverse 2 times VBD by V, right? Option B is given VAB is equal to VDC. Is it possible VAB is equal to VDC? What is the guarantee that it's going to be right? It's not. But VAD is equal to VDC I can say, because this is R, this is R. Total voltage is equally divided. And this condition was given by in the problem itself. But what is the guarantee that VAB is equal to VAD? So I cannot say. So this option is wrong. Option C, when option B is wrong, option C also, VAB is equal to, so he gave VAD. Okay. VAB is equal to VDC, VAB is equal to VAD. In fact, VDC is equal to VAD. Therefore, when VAB is not VAD, then how come VAB is equal to VDC? So both options are wrong, right? I hope you understand the point. Then remaining left over what? Option A and D, theta is equal to tan inverse, right? Magnitude VAD by P. These are the options given, right? So let's look at. Now these kind of problems can be handled with only phasor diagram approach, okay? So if you assume this is, let us say I, let me draw the phasor diagram. Let me draw the phasor diagram here, okay? So I is the reference phasor, but you know that AB is in series with what, in phase with what I, so this is VAB, VAB, that means this, if this is A, this is going to be B, okay? Then VBC, what is VBC? Assume that this is a positive angle, okay, assume that this is a positive angle, set it an angle of theta, then VBC definitely leads I by how much angle? Theta. So let me draw this. VBC. That means if this is B, this is going to be what? C. Then this total voltage is going to be what? V. Yes or no? VAC. VAC is nothing but VAB plus VBC phasor addition. VAC is equal to VAB plus VBC. Yes or no? Phasor addition. So this is nothing but VAC. We can say VAC. Okay. Now, what is saying actually here? Now this is adjusted such a way that VAB is equal to VBC. Understand? VAB is equal to what? VBC. This angle is theta. Now he is saying VAB is equal to magnitude VBC. Okay. It implies that the angle here, angle phi, let us say, the angle phi becomes angle theta by 2, because when equal magnitudes are there, this resulting phasor will bisect the angle between these two. Yes or no? Agree all of you? Yes, definitely. Now this is very, very important. And one more important observation from the circuit itself, that VAD is equal to VDC. Yes or no? VAD magnitude is equal to VDC. I hope you understand. VAB is equal to VBC, already given. Based on that, I can say phi is equal to theta by 2. VAD is equal to VDC. It is clear from the circuit itself, because R and R both are same, and the total voltage will be divided equally. Okay, which is equal to VAC by 2. Understand? Now, when you have these two conditions, VAB is equal to VBC. Okay, VAB is equal to VBC, and also VAD, that means point D is selected on AC such a way that VAD, this is VAD, and this is how much actually here? This is how much actually here? VDC, because this point is D. Then you have definitely the angle of ADB, then the angle of ADB is going to be 90 degrees. So if it is 90 degrees, I can apply tan phi is equal to, okay, what is that? VBD, because anyway is magnitude, by, okay, magnitude by VAD. Yes or no? VAD. So from this I can say, but what is this phi? Tan inverse, okay, VBD by, you know that VAD is nothing but VAC by 2. Okay, VAC by 2, where VAC is nothing but what? V only, V by 2. So therefore V by 2. Understand? This 2 will become, but angle phi is nothing but what? Theta by 2, bisecting, right? So tan inverse 2 times VBD by V. Finally, you are left with theta is equal to 2 times tan inverse 2 VBD by V. You understand all of you? Okay. So this is how you solve the problem, purely phasor diagram based approach. Understand all of you? The data given VAB is equal to VBC. I have utilized the data. And I know that VAC is equal to VAB plus VBC. Based on that, I can draw the phasor diagram. Whenever I draw the phasor diagram, I need to list out all the phasors, right? VAC, VAB, VBC, then I, then VAD, then VDC, and so on. All these phasors have represented here on the phasor diagram. And this phasor diagram, I hope you remember, I have explained you in the phasor diagrams concept. Now you see how the phasor diagrams are applied to a circuit. You understand? The circuit is designed, okay? The circuit is designed in such a way that that phasor diagram, what we discussed, is so much useful here. So it's very, very interesting problem. You have to work out, you have to practice a lot to understand such kind of problems, okay? There are some special problems, 2 or 3 are there. So you just put some extra efforts to understand. And all remaining problems I'm telling you, you can easily solve them. Only these kind of problems, you need to put some special efforts, okay? So I stop the session here and we are going to discuss next session some more problems. Even I would like to take some theorems, okay, in the next class. AC theorems, we will see. AC theorems, DC theorems, there is no difference, right? Okay, only you are dealing with the complex values in AC theorems. But maximum power transfer theorem is different in case of AC as compared to DC. That we'll see in the next class. I stop the session.